Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about graphing the abstract linear equations. And here our directions are to create a chart for 5 of the solutions to each equation, and then graph the set of all the solutions to each equation. So here we have 5 different equations, parts A, B, C, D, and E. And in each equation, I'm going to show you how to get part A and B. So let's just start with part A on letter A. I'm sorry. The first example here, 3x minus 1, part A, find 5 solutions to the equation. And really, when we're doing this, when we're finding 5 solutions, what we're doing is we're basically choosing a value for the independent variable, which is x. So the independent variable is x. And then we're doing the calculations here in this part, and then we're outputting a value for y, which is the dependent variable. So we can say dependent variable is y. So let's say, for example, if I wanted to say that x, the independent variable, was 0. So when x is 0, so when I plug in 0 for x, I get 3 times 0 minus 1, which is 0 minus 1, which is negative 1. Okay, so when x equals 0, here, y equals negative 1. That's a solution to this equation. And the way we can make that into the chart is we say x, the independent variable, when that's 0, then y, the dependent variable, is negative 1. And we can use that same concept for 4 other types of solutions. So let's say if I had x is 1 here. So x is 1. That would mean 3 times 1 minus 1, 3 minus 1, and you'd have 2. So y equals 2. So when x equals 1, y equals 2. And you can continue on in that process and get 5 different solutions. And it really doesn't matter which values you choose for x, because there are infinite many values you could choose for x. I typically choose ones that are close to 0, like 2, negative 1, and negative 2. And those are typically the ones I choose. But again, you can choose any ones that you want. Here, when x is 2, y is 5. When x is negative 1, y is negative 4. And when x is negative 2, y is negative 7. So that would be a chart. This here would be a chart of 5 values to make this equation true, or 5 solutions to make this equation true. Now, that's part A. Part B, then, it says make the, let me write the chart in here. Part B, when you make the graph of all the solutions, you're basically going to use the information that you're given from the equation. So here we know that this equation is in slope-intercept form, which means that the 3 here is our slope. So the 3 is the slope, or m, and the negative 1 is our b. And remember, this is in the form y equals b plus or minus mx. It's a slope-intercept form. So if we have a negative 1 starting point, so we're going to start negative 1 with b. And then our slope is 3, so we're going to go up 3 over 1 to the right, up 3 over 1 to the right. Or you can go opposite, down 3, 1 to the left. And so when we create this line, we're actually creating the set of all the solutions to this equation. And that's what the arrows mean here. The arrows indicating that, hey, this line travels in both directions forever. And so there are going to be infinite many solutions on this line. So each dot on the line represents a solution. So let's check that idea with our chart, because we know we have, in this chart over here to the left, we know we have 5 solutions that are part of this equation. So let's check that. You have the first one here, 0, negative 1. That would actually be the solution here to this equation. Then you have the solution 1, 2. So that would be this solution. Then you have the solution 2, 5, which would be this solution here. And then you have the negative 1, negative 4 solution. That would actually be this one. And then you could go on, keep going on forever and ever and ever. So the graph here, the red line, is the set of all the solutions, and the chart is just a set of 5 solutions. So let's look at part B. So in part B, we know that the independent variable, again, is x, and the dependent variable is y. So on the left there, you have the chart of 5 solutions. And then, again, let's use our equation here at the top to actually create the graph of all the solutions to the equation. So we have a starting point of positive 2. So we're going to start here on the graph. And then we have a slope of negative 1/2, so we're going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Or you go opposite. Up 1, left 2. Up 1, left 2. Up 1, left 2. And we create our line. And make sure you have the arrows on there, because the arrows indicate that it goes in forever in each direction. And then we can check our solutions, the red line being the graph of all the solutions. We can check some of the ones that we have on our chart. So like 0, 2 would be this dot here. You have 1, 1.5, so you have 1, 1.5, which is about right here, so that's approximately right. Then you have 2, 1, so 2, 1 would be this dot here in the green. Then you have negative 1, 2.5, so negative 1, 2.5 would be right here, so that's about right. And then lastly, negative 2, 3, which is this dot here. So yeah, those do check out as solutions to this graph. Let's now look at part C. So part C again, the independent variable is x, dependent variable is y. And in this equation at the top here we have the y-intercept is 0. So our starting point is going to be 0, 0. And that makes sense with what we have on our chart here to the left. And then we're going to use the slope. 3 halves, so we're going to go up 3, right 2. Up 3, right 2. Or you can go down 3, left 2. Down 3, left 2. Okay? Then we create our line. That's not really a straight line there, but you get the idea. Make sure you have your arrows. And again, we can check dots here with the 5 solutions that we came up. So 2, 3. 2, 3 would be this dot here. Then negative 1, negative 1.5 would be... ooh, this line really didn't turn out that well. It's going to be right here, and if my line were straight, it would actually go through there. So let me try and make that line a little straighter. There we go. So that's a little bit better. And negative 2, negative 3. Negative 2, negative 3, so this bottom dot here would be this one. So let's move on to part D. Part D, this one's actually kind of a strange case. Since there's no x value, really when we do this, we're saying that there's like a plus 0x here, because the slope is 0. And when we graph this, we actually create a straight line, a horizontal line, starting at negative 4, because that's my y-intercept. And then it's a horizontal line. And since I own the values that I put in for x, whether it be 0, whether it's 1, whether it's 2, whether it's negative 1, whether it's negative 2, whatever values I put in for x up here, it's always going to be negative 4 for y. So that's why the chart looks the way it does. It's got all those negative 4 values. So, and that makes sense with what our line looks like, because if we plot all these points, this is like 0, negative 4. That'd be 0, negative 4. That'd be this dot here. If I plot 1, negative 4, that'd be this dot right here. If I plot this point here, 2, negative 4, that'd be this dot right here. And then so on and so forth. You get a negative 1, negative 4 would be right here. And so those are all solutions to this equation. Now let's look at part E. Here we have our, again, our dependent variable is y, independent variable is x. And we use our starting point here of 3 to say this is where we're starting the graph. And then our slope, of course, is negative 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth. Or we can go up 1, left 1, up 1, left 1, and then create the line with the arrows. Arrows are important. And then, again, we can check some of our solutions in our chart with 0, 3 being this dot here, 1, 2 being this dot here, 2, 1 being this dot here, and then negative 1, 4 being this dot here, and then negative 2, 5 would be this dot here. So yeah, those all check out as solutions to the equation. So tonight for your homework, you're going to have 5 problems to work from. And the directions, again, are A, to create a chart for 5 of the solutions to each of the equations, so numbers 1 through 5, and then graph the set of all the solutions to each equation. So you have 5 problems to work from, and this will be due on Wednesday.